Imagine a world where the idea of nothing as a number just didn't exist. It's like trying to bake a cake without an empty bowl to start with. People could count things they could see and touch. 1 sheep, 2 apples, 3 friends. They had numbers for things that were there. But a number for something that wasn't there? That was a mind-bendingly tricky idea. This wasn't because ancient people weren't smart, they were incredibly clever. They thought about numbers tied to the physical world. So, you might use a pile of pebbles. For every sheep that goes out, you put 1 pebble in a bag. If the bag is empty at the end of the day, you know all your sheep are back. Now let's take a trip back in time to visit some amazing ancient civilizations and see how they wrestled with numbers. First stop, ancient Rome. The Romans gave us magnificent aqueducts, straight roads, and Roman numerals. IVXLCDM. They're great for carving into buildings, but try doing long division with them. A big problem was that they didn't have a placeholder. Let's travel over to ancient Mesopotamia, to the Babylonians. These folks were incredible astronomers and mathematicians. They developed a number system based on the number 60, which is why we still have 60 seconds in a minute and 60 minutes in an hour. They were way ahead of the Romans because they did have a concept for a placeholder. At first, they just left a blank space, which could be ambiguous. Later, they added a placeholder symbol, a huge step. For the next part of our journey, we have to travel to ancient India, around the 7th century CE. This is where something truly remarkable happened. This is where nothing finally became something. Indian mathematicians and thinkers weren't just content with having a placeholder. They started to think about nothingness, or shunya in Sanskrit, as a concept in philosophy and spirituality. This cultural readiness may have unlocked the mathematical puzzle. They were the first to treat zero not just as a space but as a number with its own properties. A brilliant mathematician named Brahmagupta is one of our heroes. Around 628 CE, he wrote a book where he laid out the rules for using zero. He explained, when you add zero to a number, the number stays the same. When you subtract zero from a number, the number stays the same. When you multiply any number by zero, you get zero. Brahmagupta even tried to tackle division by zero, a problem that still trips us up today. The new number was represented by a simple dot, later evolving into a small circle, the ancestor of our zero. That little circle became a full-fledged member of the number family. So this incredible invention, the number zero, was born in India. But how did it get from there to, well, everywhere else? Ideas like people travel along trade routes. The new Indian number system with its 10 digits, including zero, was so useful. Merchants and scholars who visited India saw its power immediately. Arab and Persian scholars in a golden age of science were fascinated by this new system. One of the most important people here was Muhammad ibn Musa al-Khwarizmi. His name even gives us the word algorithm. Around 825 CE, he wrote a book explaining the Indian system, including zero, to do calculations. It spread through the Islamic world and beyond. His book was translated into Latin, a key step, but Europe was slow to adopt. Some even found the new numbers suspicious. In 1202, Fibonacci published Liber Abaci after learning the Hindu-Arabic system, and he was convinced it was superior. Merchants, bankers, and scientists gradually adopted the new system. From India to the Middle East to Europe, zero completed its long journey. So why do we care so much about a number that means nothing? Because this nothing is everything to our modern world. The arrival of zero wasn't just a convenience for accountants. It revolutionized mathematics and science. How can you solve for x in an equation like 5x minus 10 equals 0 without zero? It's the anchor point. 1, 2, 3 minus 1 minus 2 minus 3. Without zero, we couldn't easily represent debt or freezing temperatures. Calculus studies what happens when things get infinitely small, approaching zero. Without zero, we couldn't calculate the orbits of planets or design bridges and skyscrapers. If you enjoyed that, hit like, smash that subscribe button, and ring the bell so you never miss a moment of history, science, or brilliant ideas on Inventor of Science.